All right, this next example is going to ask us to write an equation, approximate the value in 3 years, and then approximate the amount of time it's going to take this car's value to decrease by half. So it's two parts. Question reads, value of a $20,000 car decreases 30% each year. What will the car be worth in 3 years, and how many years? Will the value of the car be about half of its value when new? So, first part, let's just structure the equation, right? The initial value is $20,000. It is an exponential decay from decrease here. It's got a 30% decay each year. So that's going to give us an R value of zero point 0.3. And our time we're going to work with is 3 years, right? So set up your decay model. A of t equals a sub 0 times 1 minus r to the t. Plug your values in. So a of 0 is 20,000, r is 0.3, t is 3. Calculate it carefully. Gives us about $6,860, right? So in 3 years, this car is going to be worth $6,860. Now, second part of the question reads, how many years will the value of the car be about half of its value when new? So half of the value is literally half of the value. So if the car's $20,000, half of that value is 10,000. So that's an A of t value, right? So we're looking for the amount of time it's going to take a $20,000 car here to equal $10,000. So we're going to set it up in this equation, and we're going to start isolating the variable term factor, right? So that's going to be the 1 minus r to the t factor. So we're going to divide both sides by 20,000. Anytime you're dealing with half of its value in this situation, when you do this division of 20,000, you're going to always be left with 0.5, right? So zero point 0.5 equals 1 minus zero point 0.3, or zero point 0.5 equals 0.7 to the t power. And at this point, since we're solving for this exponent, we're not going to use a guess and check. We're actually going to go straight to the logarithm, right? So if you remember from the earlier example, to solve for t here, you're going to take the natural log or log of zero point 0.5 and divide it by the natural log or log of 0.7, and that'll approximate the amount of time it's going to take a $20,000 car to decay by half its value. So in this particular case, that's only about 1.94 years. Not, this card does not hold its value very well based on the the decay rate of 30% per year, right? So a quick reminder, if you're solving an exponential equation, m equals n to the t, you can solve for t by taking the natural log of m, dividing it by the natural log of n, or you take the log of m divided by the log of n here. And again, if you can't find the natural log or log keys in your calculator, do a quick search for the model of your calculator and log key or natural log key. Next example, similar. The value of a $24,000 machine decreases 9% each year. What will the machine be worth in 3 years? And again, how many years will the value of the machine be about half of its value? So two parts. We're going to structure the first part in a similar fashion. So the initial value of this machine is 24,000 times 1 minus 0.09 to the third power. That's going to be approximately $18,085, right? Pretty simple. Make sure you document this line here in your work. And then for the half the value, right? So half of $24,000 is $12,000. So we're going to set our equation equal to $12,000. And we're going to solve for, or we're going to isolate the exponential factor here, 0.91 to the t. So divide both sides by 24,000. This side is always going to end up producing 1/2 or 0.5 equals 0.91 to the t. And again, to solve for t, we take the natural log of 0.5 divided by the natural log of 0.91, or you could use the log of 0.5 divided by the log of 0.91. That gives us approximately 7.34 years. So in this case, this machine will be valued by half in about 7.34 years.